Sahara Desert reach temperature up to 80 degrees Celsius, stretching over roughly 9 million square meters. This massive desert receives about 22 million terawatt-hours of energy from the sun every year. That's well over 100 times more energy than humanity consumes annually. So, could covering the desert with solar panels solve our energy problem for good? Solar panels work when the light particles hit the surface with enough energy to knock electrons out of their stable bounds. On their journey back to stability, these electrons produce electricity. However, there's a limit to how much power panels can generate. Solar panels can only interact with certain wavelengths of light, making it impossible to convert all half of the sunlight they receive. And even light particles, they can convert often bounce off them without ever hitting an electron. But thanks to clever scientists and engineers and sustained government investment, solar panels are generating more electricity than ever. Anti-reflective coatings and patterns on the panel surface create more opportunities for incoming light particles to hit electrons. These techniques have increased commercial solar panel efficiency from the low teens to 20%, with experienced models reaching up to 47%. That's more solar has got 89% cheaper over the last decades, thanks in part of global supply chains for other technologies that use in the same material. Together, these factories have made solar panels the cheapest source of energy on Earth. Countries including India, China, Egypt, and the US have already taken these new panels into the desert. Their massive solar farms range over from 15 to 56 square kilometers. And when the sun is high in the sky, these plants can provide energy for hundreds of thousands of local residents. But these farms also get extremely hot. Light that solar cells don't convert or reflect it absorbs as heat, which will reduce a panel efficiently. And the cooling system employed by many farms can use huge amount of energy powering fans or moving water. To maintain optimal temperatures. Even with these systems, solar panels in the desert absorb far more heat than the natural sandy environment. This has been a problem on the scale of existing solar farms. But if we try to cover the Sahara, this effect could create massive change in the region climate. Constructing solar farms already disrupt local ecosystems, but a plant of this scale could dramatically transform the desert landscape. Thankfully, solar panels aren't our only option, and some of the largest solar plants in the world are trying a new approach. Giant mirrors. Morocco Noor Power Plant, which will eventually cover roughly 30 square kilometers in the Sahara. It is a concentrated solar power plant. This design reflects light onto a receiver, which converts that energy to heat and then electricity. These mirrors do create a dangerous temperature shift for local wildlife, but they have less potential to transform the landscape. And if it takes time for the materials being heated to cool off, these plants often continue producing electricity past sunset. Whenever they use panels or mirrors, industrial solar farms are often easy to fit into existing energy infrastructure. However, getting their electricity beyond local power grids is much more difficult. Some countries are working on a way to connect electric grids across the globe, and many farms don't store energy in massive batteries or convert the electricity into clean gas can be used later. But right now, these techniques are still too expensive and inefficient to rely on. Worse still, industries renewable can share some of the same problem as fossil fuels. Rely on destructive mining operations and carbon-emitting global supply chains. Unfortunately, solar can exist on many scales, from industry solar farms to smaller installations that power individuals, buildings, and rural communities. These projects can supplement energy use or provide a massive source of energy for a region of the grid. And since solar panels rely on a few simple components, they are quick to install and relatively easy to update. In fact, it's this flexibility that enables solar to become so cheap and ubiquitous over the last decade. So, if we want to keep up with humanity's rising energy use, we need answers both big and small.